My name is Sophie Ruehr, and I'm a first-year PhD student at UC Berkeley. Today, I'll be talking about using satellites to study plants and climate change. For those of you interested in climate change policy, you may have heard the term net carbon neutral, bandied about by people like Joe Biden or folks on the Intergovernmental Panel on Climate Change. Many countries have come up with climate neutral targets to become net zero greenhouse gas emitters by 2050, including the United States. I'm interested in this term net zero. A lot of countries have committed to transitioning to green energy sources like solar or wind, but part of their plan is also planting trees to sequester carbon that we emit to the atmosphere while we burn fossil fuels. So plants are natural climate change mitigators. As they perform photosynthesis, they basically eat carbon out of the air and store it in their leaves and roots and bark. This is a figure showing back from 1750 to the present day of carbon emissions to the atmosphere and sinks of carbon from the atmosphere. So you'll see an exponential increase in carbon emissions due to fossil fuel burning, and as well as deforestation in this brown color. This dark blue represents carbon absorbed by the ocean. Light blue is just the carbon that is freely floating around in the atmosphere. And then this green area is the land sink. This represents all the carbon that's getting sequestered every year by plants on the land and on Earth. So you'll notice a few things about this, and these are areas of great uncertainty. There's been a really large increase in this land sink over the past few decades, and one source of uncertainty is we're unsure whether this increase will continue over time or might max out at a certain value when plants just can't eat enough carbon to continue that increase. And what I'm especially interested in is this huge amount of interannual fluctuation in the land sink. You'll see some years it's actually positive when the land is actually emitting more carbon to the atmosphere than it's eating. And other years, it's a really big negative value. I personally think that some of this interannual variability has something to do with water and drought. So we can start answering some of these questions and uncertainties about the land sink by using satellites. Satellites are really cool. There are a bunch of them floating up in space, orbiting Earth, and taking pictures of the surface with fancy cameras. And we can use this historical data to see over time how the Earth is changing. Another cool thing about satellites is that they can see things that humans can't see with our naked eye, like groundwater and different layers of groundwater. It can also see things like plant growth over time. This is showing plants gaining their leaves in summer and then losing them in the fall. And one of the first research studies I'm preparing to do is comparing these two sets of data to understand historically how different layers of groundwater are affecting plant growth. I'm hoping that water might explain some of the variation we see in the land sink, with dry years resulting in less carbon sunk and wet years resulting in a much larger carbon sink. I'm also interested in predicting forwards if we know that drought and temperature extremes might increase with climate change, how that will also affect the carbon sink. Thank you so much for your attention and for your ARC support.